Hello everyone, welcome back to Chemistry 24x7 series. In this series, we are exploring the important previous year questions. If you are new to this channel, don't forget to subscribe. Today, we are going to solve this problem which is based on LDA. So this is the question from CSIR 2014. According to this question, cyclohexanone react with LDA and followed by allyl bromide which produce compound A. This compound A further react with palladium chloride, oxygen, copper chloride in the presence of DMF water which produce compound B. This compound B further react with sodium ethoxide and followed by acid workup which produce this bicyclic compound. The first part of the problem is relatively simple while the second part of the problem is slightly hard. However, if you have the idea about the named reaction, this part is simple, or otherwise, if you have the idea about retrosynthetic analysis, the second part also will be simple. Okay, let's solve this problem together along with the magnetic details behind in this interesting transformation. The first step is the treatment of cyclohexanone with LDA. So LDA we already discussed in our channel. So LDA is one of the sterically hindered strong non-nucleophilic base which readily takes the proton from less hindered site. So according to this, here you see here there are two sides. So therefore our LDA will take the proton from any one of the side which leads to provide this corresponding inlet ion. So this inlet ion quickly react with allyl bromide by SN2 prime mechanism to yield this corresponding allylated ketone as a product. So now you look the second step. The second step of the reaction is the treatment of palladium chloride, oxygen, copper chloride and DMF water. So I already said this reaction condition based on one name reaction. So here you see this is that name reaction. That name reaction is called Wacker oxidation. According to Wacker oxidation, terminal alkene under this palladium catalyst condition that will convert into the corresponding alpha methyl ketone. So here closely look only the one difference between these two reaction conditions. Here they used copper 1 chloride, but here according to Wacker oxidation condition is copper 2 chloride. So this one is doesn't matter if you use either copper 1 chloride or copper 2 chloride. When you use copper 1 chloride under this reaction condition, that will convert into the copper 2 chloride. So let's see the catalytic cycle for better understanding about Wacker oxidation process. According to this, palladium chloride that readily convert into the corresponding active catalyst by the coordination of ligand. Here ligand means solvent. Here in this reaction condition, we use DMF water as a reaction medium. Therefore, water readily coordinate with this palladium center result to get corresponding active species. This active species readily coordinate with alkene. So because of this coordination, here you see one of the chlorine coming out. Now this whole complex will be a cationic complex. So this particular process called complexation, then followed by the complexation, water react with this intermediate. Here you see that water has two, oxygen has two lone pair of electron, one of the lone pair of electron regioselectively attacks this alkene, particularly this carbon, then followed by this electron attacks the palladium center. So due to the steric reason, this water regioselectively attacks this particular carbon. So which yield this corresponding intermediate along with hydrochloric acid elimination. So this particular step is called hydroxypalladation. So the next step, beta hydride elimination takes place to produce this corresponding enol form. So the enol form readily convert into the corresponding keto form by ketoenol tautomerism along with this intermediate palladium species. So this particular step is called beta hydride elimination. So after the beta hydride elimination, which readily undergo reductive elimination to yield palladium 0. So this palladium 0 quickly convert into the corresponding palladium 2 complex by copper chloride oxidizing agent. So here you see in this condition, when you take the copper chloride, which readily convert into the corresponding copper 2 chloride by the treatment of HCl and oxygen gas. So HCl here you see already our catalytic cycle produced 2 equivalent of HCl, then oxygen when react with oxygen gas which produce water as well as copper 2 chloride. This copper 2 chloride convert palladium 0 to palladium 2 plus active catalytic form. So based on our Wacker oxidation process in this particular intermediate which readily convert into the corresponding alpha methyl ketone. Next reaction condition is sodium ethoxide. The sodium ethoxide readily takes the proton from here which generate corresponding inlet ion. So this inlet ion quickly attack this carbonyl carbon intramolecularly, which is cyclized to provide this corresponding intermediate. So when you treat with acid, which readily convert into the corresponding this form, corresponding product. So this particular step is called intramolecular Aldol reaction. In this way, one single question covering series of topics. The first one is LDA, the second one is SN2 prime mechanism, the third one is Wacker oxidation, and fourth one is intramolecular Aldol reaction. So based on our discussion, so we can easily omit this option 2, 3, 4. So the correct option is number 1. So based on this, so this one is the correct answer for this question.